everyone. I'm Paul Fremantle and I'm the CTO of WSO2, and I'm going to be leading this webinar today. I'm hoping to make it like at least 60–70% demo, and so it may well go wrong, but that should be more fun for you. Get to have a little laugh at me if it does. So please ask questions. I'll try and get to them if they come up, if they're relevant, or we'll definitely get to them at the end. And I hope you enjoy it. But before I do the demo, I just want to kind of set the scene a bit. So I'm just going to talk for 2 or 3 minutes on really why we built Ballerina and then go straight into the demo. So I hope you can see my screen. So basically, companies like Uber, Netflix, Google, Amazon are scaling massively to meet customer demand. And as they do that, if you look at their architectures, they are increasingly disaggregating and building disaggregated architectures to do that. And this is not a new thing. This is something that we've seen over five decades. Basically, microservices, serverless APIs are kind of the inevitable result of a trend that's been happening and are becoming the norm for everyone. And as those disaggregated endpoints become network accessible, they become, programmable network endpoints, whether it's APIs, microservices, serverless functions, data, apps, and everything's becoming a programmable endpoint. And the number of these programmable endpoints is exploding. And I think this is all fairly clear. Now, the interesting thing about this is that the apps that we're building, the cloud native applications, are increasingly dependent on these endpoints. So effectively, we're building applications that are talking over the network to massive number of endpoints. And integration is the discipline of resilient communication between network endpoints. And it isn't easy. There are lots of techniques and technologies that have been designed to help build resilient systems, whether it's distributed transactions, circuit breakers, events, and then there are things like security, workflow streams, and compensation. And so all of these things are hard problems to solve. Now, in the past, we've typically had 2 ways of solving those problems. On the left-hand side, we've used technologies like Enterprise Service Bus, Business Process Manager, EAIs, and I've been deeply involved in building these for 20 years. And these things understand integration and they try and make integration simple, but they have one big challenge, which is that they're not agile. So on the other hand, you can use a general purpose programming language, and there's lots of things like Java, Node, and people are using these. And the challenge with these is that they don't understand integration and they're not integration simple. And so the developer has got to take responsibility for either solving those problems or finding a framework that adds them. So, for example, Spring Integration, Camel, these are common frameworks people add into their systems to solve these problems. And these are complex bolt-on frameworks that don't necessarily make it that much easier to do integration. They still have a high learning curve and complexity. So we've kind of come to the conclusion that there's something we call the integration gap, which is this: you can either be agile but not integration simple, or you can be integration simple but not agile. And me and the team I work with have been involved in 20 years of building projects, integration projects. We've worked on thousands of these projects, and almost every project has ended up on one side or other of this integration gap. So 3 years ago, we set out to build a new language to overcome this problem, and the result is Ballerina. It's a programming language and a platform which are co-designed together, and we believe this is an approach that is both agile and integration simple. And we think that it seems a bit crazy to build a new language, but as you look at it, it starts to become a compelling approach to solve this particular problem. So we're going to take a look at this, and I'd really appreciate your feedback, either directly during this webinar or on the Slack channel or via the dev mailing list and so forth, or by Twitter. You know, I think the conversation is something we're really keen to get going. So Ballerina is a compiled type-safe concurrent programming language, and it has some design principles. It's sequence diagrammatic, it has a network type system, it has worker concurrency, it has a package and cloud-aware build model. I think you'll see these as I go into it, so I don't really want to dive into those too much at this point. Let's just start by coding a hello world. So I've got Ballerina installed, and I'll talk later on about exactly what I've got installed. And I'm going to use Visual Studio Code. There is a plugin for Visual Studio Code that understands Ballerina and does tab completion and stuff, so I think that's kind of useful. So I'm going to start that, and you'll see I've got a brand new directory, and I'm going to start a brand new file, and I'm going to call it demo.bal. So it's a normal kind of programming language. We want to import packages, we can do that. So I'm going to start out. The hello world in Ballerina is a network hello world. It's an HTTP, so we're going to import HTTP, and we're going to create an HTTP service. And a service is a first-class concept in Ballerina. This is a network endpoint that's listening for requests and answering people. And I'm going to call this service hello. And services have resources in the HTTP world that maps to a get, put, post, or to a particular URL. And you can see that we get past a reference to the caller and the request they've sent us. And you can just, it's a normal programming language, so I can sort of say var header names equals request dot get header names, and that will return me an array of strings. And I can say var error equals caller arrow respond, and I can say hello world. So there we go. Now I don't really need that header names, but I wanted to make a point here. So this dot here, request dot get header names, indicates this is a local method call. And that's perfectly normal in programming languages. And that's because we've already got the request, we're in memory, the request is just a memory object. But when we talk to a remote endpoint, the caller, that's a network call. And instantly you can see there's a different syntax involved here, which is this arrow. This arrow is indicating that we're making a network call, and this is a distributed operation. And I think this is really cool, because whenever you do concurrency, whenever you do asynchronous, whenever you're talking to a third party, this arrow is indicating that something is not local, and that therefore there is something to be aware of. Now I'm just going to delete that. Now I've made that point, and also we don't need this error, so we can just use this syntax to say, you know, don't worry about what returns. So we've pretty much done everything to create a network port. The one thing more, we need to bind this to a network. We need to bind it to a network listener port, and I'm going to bind it to port 9090. And now we're going to see that this is a compiled language, so we're going to compile that, and I'm going to run the compiled thing, which is this balx file, and that's going to start a listener on port 9090. And now I can do a little curl on it, localhost 9090/hello, which is the service, and /hi. So the port is the URL is created from that. And we have hello world, and that, I hope you can see in those 7 lines, has created a simple network listener. So that's a good start. We've done hello world, so I've got a caller, they're doing a get to this hello service, and it's coming back with hello world. But we can also do some annotations. So I can basically come in and say, I want this HTTP service on a different path or some different method, and you can see there's a set of things here, the endpoints it listens to, the host, the base path, whether you do chunking, there's course support, versioning, there's authentication support built into this. I'm not going to do any of that. I'm just going to set the base path to be /, And I can also go to this resource and I can do some resource config, and I can set the path again to be slash, and I can say I want this only to respond to a post. So I can basically set the post method on it, and then I can grab some data from that post. So I can say the body of the message is a request.get get text payload, and that is almost right. But let's say I want this to be a string. One of the things about Ballerina is it's a type-safe language. So it's saying that this is you're expecting a string, but actually this could be a string or an error, because whoever made the post request to this might not have passed a text payload. They could have passed a different data type, or they could have passed no payload. So we can do error handling, but there's a kind of easy get out of jail free, which basically is to say check if it's an error or not. And so I'm going to do that as the simple way, and I'm going to change this now to say hello plus body, and now we can pass in a body into this message, and we can hopefully get back something. So if I rebuild that, now this time I'm going to have to curl just 1990, but I'm going to have to explicitly make it a post, and I'm going to have to pass a body. So I'm going to say hello webinar, and I'm going to go and run that, and hopefully I've got it all right. Hello webinar. Awesome. So we've seen some simple annotations. We're now posting the name. We're getting back hello name, and but so far we haven't done any integration. So let's now look at calling a remote service, and we're going to use a connector to do that. So the service I want to call is Twitter, and I'm going to do a little tweet. And Ballerina has a package manager, so this is a bit like npm in Node, pip in Python, various things. It's built into the language. So I'm going to do a search on Twitter and see if there's a Twitter connector out there. And it's gone over to the internet and it's found a Twitter connector, and I'm going to pull that in to my into my workspace, and I'm going to pull that Twitter connector in, and then I can use it inside my inside this program to do a tweet. So I've pulled that in, and now I can go and import that connector. So I can go import WSO2 / Twitter, and it should have found that. I don't know. Let's see if it's just taking a second to find it. But no, let's assume. But normally you get the command completion. It probably will take a minute for that to kick in. And I just wanted to show you one more thing, which is that this thing I've bound to there, the port, there is really something we call a listener, and it's an endpoint as well. So basically, every remote endpoint is represented by this object called an endpoint in the language. And I'm going to just do port 1990, and I'm going to bind it to that listener there. So it's just saying exactly what we saw before, but in a little more detailed version. So the Twitter endpoint is also another endpoint. So in other words, we are also going to call a Twitter endpoint. In this case, we're going to call a Twitter client, and I'm going to name that Twitter. And that endpoint is going to need some config. So basically, it needs to know my secrets. So in order to call Twitter, you need a OAuth2 access token, an access token secret, a client ID, and a client secret. So those are the things I need to provide it. Now, obviously, I don't want to type them into my code here. So what I'm going to do is I'm going to import a config library that's going to allow me to read some config. And I have a little bit of ready written code here that's going to help me if I edit that. So I'm going to cut and paste that into there. So that's basically going to say, go to a config file and read all those secrets from that config file. And that's going to help me. So now I want to, instead of just sending that message back, I want to tweet it out. So let me just comment out that line. And now I'm going to say I've got some kind of status, and it is the tweeter arrow. And here you can see, here are the different methods that are allowed by that Twitter connector. So you can retweet, you can search, you can find a status, you can get trends, you can destroy a status, but I just want to do a tweet of a status, and that status is just a string. So I'm going to say hello from hashtag ballerina, and I'm going to add in that body again, so we're still taking some data from the message, and we're going to tweet that. And again, that could return an error. And for the moment, I'll talk about how we deal with errors and error handling in a minute. But for the moment, I'm just going to deal with that error. And now I have some kind of status object. And what I can do is I can do things like I can say, well, there's an ID in that status object, and I can grab that ID from there. You can see there's a whole bunch of basically things like the created at, the ID, the retweet count, retweeted, and so forth. So this is all the data that Twitter's giving me back. And one of the really nice things about this being a type-safe language is that this connector is a type-safe interface to Twitter. And because it's typed, I have all this command completion, which is really helping me out here. And we can get the string created at equals status dot created at. And now we can just send back, say, that created at to the client. So we can say caller arrow respond created at. And so now we should have a very simple little program that's going to take a message coming in a post. It's going to tweet that with a little bit of extra stuff. It's going to get the ID and create date, and it's going to respond with that. So I'm going to recompile that. And this time when I run it, I need to pass that config file over. So I have some of you may have come across something called a TOML file. A TOML file is a type of, it's like YAML, it's a bit easier to read. I would show it to you, but it's got all my Twitter secrets in it, and this webinar is being recorded, so I don't really want them in the recording. So I'm not going to do that, and I'm going to run -config, pass the Twitter TOML and demo.bal x, and now it's listening, and I'm going to do that post, and you can see a create date has come back. And if I go and look at my Twitter feed, you can see hello webinar from Ballerina tweeted 7 seconds ago. So this really has worked. So I hope you see that in, what is it, about 15 minutes, we've created a simple a simple get service, a post service. Now we're calling a Twitter connector. One thing I think is really nice is that we designed this language around the concept of sequence diagrams. And you noticed I was using sequence diagrams to demonstrate and talk about what we're doing. The whole language is built around sequence diagrams, and it's isomorphic to a sequence diagram. So you can see here, this sequence diagram that I've just created by pushing that little button up in the corner, that is not predefined, that is created from the code. And it's showing us exactly what's happening here. The caller is making a request, to a default worker. The default worker is doing a little bit of logic. It's doing a tweet to the tweeter endpoint. It's getting the response back, and then it's passing that created at back to the caller. So I think that's really, really pretty sweet. The sequence diagram is really, really useful for really showing other people what you're doing with this code, checking that it's really doing what you think it's doing, and also when it comes to debugging, this kind of visual view is really useful. So we've seen a connector, and we've done that exactly what's in that diagram. I think the generated one's actually is even nicer than the one that we drew. And now, a typical problem in integration is some transformation. So what I want to do is define a bit of an object, some kind of record structure in JSON that I'm going to read in, and I'm going to take the name from that JSON, and then I'm going to create a JSON response. And I'm going to using that, I'm going to show you two aspects of the JSON handling inside this language. So let me just close that. So the first thing I can do is just create my own type. And if I do a type, you can see that so I'm going to call this a person, and it's a really simple type. It just has a string name in it. But every type in Ballerina can be mapped straight. Any record type, which is a basic type. There's kind of two types. There's objects which have methods, but there's also these sort of struct types. Any struct can be mapped to JSON, which is really, really useful. And what I can do is effectively say that I want to pass that JSON as the body of this message. So I'm going to say that I have a variable called person, which is going to be passed, and I'm going to say it's a type person. And I can basically say that what I'm actually passing is a application /JSON. I think that needs to be an array. And what I'm producing is also an application /JSON. And so Ballerina is going to automatically say, well, okay, I've got a JSON coming in, but I need a person object. And it's going to do that mapping automatically. So now we can get rid of that text payload, and we can basically say string name equals person.name. And now I have a typed input, and I can basically do that tweet. Now, at the same time, I want to send back a JSON with that ID and the created. Now, JSON is a built-in type inside Ballerina. So I can literally just inline some JSON here, and I can say the Twitter ID is that variable ID, and the created at is that variable created at. And I can sort of do, key is value as well here, just to show you this is what kind of stuff is going on here. Oh, what did I do there? And it's telling me that it's looking fine. And now I can basically return that JSON as a response. And so now let's rebuild that. And I'm also going to put a little space in there because that was wrong. Now I've got a error because you can see I changed that body and it's a name. So I shouldn't have needed to rebuild it, because you could see it was actually highlighted in the syntax checking in Visual Studio Code. But now hopefully it'll work. And I'm going to run it with that config file. And I'm going to try curling that. Now, one of the things that Twitter doesn't like is repeated things. So I'm going to have to change the name that I send it to. I'm going to say hello from Paul. And oh dear, something went wrong. Guess what went wrong? I didn't set the content type to be JSON. So it didn't like it. So now let's do that, application /JSON, and Okay, I've got the wrong syntax there. I'm trying to think what the header is. Wait a second. Give me 1 second while I do curl header. Remind myself how to send a curl header. I should know this. Minus capital H. There we go. I knew I had it right. Just the wrong syntax. Okay, so now it's saying this isn't a JSON you're sending, because we need a JSON that's isomorphic to that person. So what I need to do is actually create a nice little JSON here. So let's do that. And now we've got a JSON, we've got the right content type, and something looks wrong there. Just fix that. And bingo. So now we've got the right JSON coming in, we've got the right content type to match that consumes tag I put on it, and it's creating a simple JSON response for me. And if I go back to my Twitter feed, you can see that it says hello Paul from #ballerina. So we've done some transformation, and I know I blew the thing a little bit there, but you can see that actually the language here was really simple. If I go look at the sequence diagram, you can see a little bit of what's going on there. It's just taking a second to generate that. It's basically showing all that transformation is happening within those double dots. So it's the sequence diagram isn't really very different from before. So I hope you've enjoyed this so far. We've done some JSON, we've done some tweeting, we've done some HTTP, but you know, part of being cloud native is doing these network things, but also, you know, how do we deploy this? Really, I want to create this Ballerina into a Docker or into a Kubernetes deployment. And that's really simple, because we have some compiler extensions that understand Kubernetes and Docker, and I can just import Kubernetes here, and I can actually start to annotate this this with some Kubernetes stuff. Now, once again, I'm going to go to my snippets file and cut and paste some stuff. So the first thing I need to do is annotate that listener, because the listener on 1990 that we're listening on is what Kubernetes calls a Kubernetes service. And so we need to give that a definition. And we also need to create a Kubernetes deployment, which is going to be the actual service logic here. So I'm going to annotate that as a Kubernetes deployment. And we also need that secrets file. So that's what Kubernetes calls a config map. And I'm going to add that config map in there. And now I'm going to kill this. And let me just show you. So I'm running Docker Edge, which includes Kubernetes. And if I do a kube control get all, you can see just Kubernetes is running. So now when I build my demo, what you're going to see is it's actually going to build all the YAML I need to deploy this into Kubernetes, and it's going to build the container. And it said, Paul, if you run kube control apply this Kubernetes file, then it's going to deploy all that. So if I just do a little tree, you'll see that as well as my demo bal and my compiled balx, I now have the YAML, the deployment YAML, the service YAML, and the Docker file for all of this. So basically generated all that. And if I just do code Kubernetes demo deployment YAML, you will see it's done all the hard work here in creating this YAML file I need. So I can literally just go kc apply -f Kubernetes, and now if I go kc get all, you'll see that I've got this Ballerina demo running on port 32531. Wicked. So now if I go to my curl and I change it to port 32531, and let's change the name so it doesn't think it's a repeated thing, and let's say hello Kubernetes, sorry, long attribute, Kubernetes, bingo, there's my Twitter. And if I reload my Twitter, now I've said hello Kubernetes from Ballerina. So I've literally taken this code and deployed it in Kubernetes, and that took me literally another sort of 5 minutes, if that, just by adding some annotations to my logic. And the same is true for Docker. So I think you're starting to see, as we build this up, that this is a very powerful language for writing these kind of network-centric systems. Now, one of the things that you get when you deploy something in Kubernetes and when you build these kind of microservices is obviously observability is a real challenge. So out of the box, we support open tracing, which is what Jaeger uses, and so you can plug this straight into Jaeger and view the interactions across the network. We also plug straight into Prometheus and Grafana, so you can actually see the number of requests a minute coming into your HTTP endpoint. You can get all the metrics out of the Ballerina runtime, and with some simple logic, we plug straight into Logstash, and from there into Elasticsearch and Kibana, and so you can actually view the logs in a distributed fashion. So, we're really trying to address these kind of challenges of building distributed microservices architectures and building this kind of integration logic that is talking to remote endpoints. Now, one more thing I want to show you is something called a circuit breaker. So one of the challenges in distributed computing is often if a remote service is down, what happens is the systems that are calling it are retrying by default. And when they retry, they tend to, when that system comes back up, it's got this backlog of requests waiting for it, and it tends to hit it, and that tends to cause a real problem. And typically what you see is sometimes systems basically crash repeatedly because they can't take that load. So a circuit breaker is a way of dealing with it, and it's a common thing in logic. So what we're going to do here is we're going to automate this tweeting by basically calling another service to get a quote from Homer Simpson. And unfortunately, that quote from Homer Simpson is a little bit flaky. It's sometimes a bit slow. And so what we want to do is if that goes down, we want to give it time to recover. And in the meantime, we're going to use some cached values or some default values or some local logic to handle the fact that the Homer Simpson quote service is down. Now, obviously, the most iconic quote from Homer Simpson is Doe. So when it's down, we're going to tweet Doe on his behalf. So let me show you what that looks like. And I've coded this pretty much from scratch. But what I want to do now is basically, let me just firstly delete that Kubernetes deployment, and I'm going to just copy a previously written file that I had written that does this circuit breaker, and start with that, just because it's very similar to where we were before, but a little bit soon. So if I show you the diagram for it, I think that will explain it a little bit better. Basically now, as well as the tweeter endpoint, we have another endpoint, which is the Homer endpoint. So when a request comes in, we're going to get a quote from Homer. And then if there's a problem, we're going to deal with that. And then we're going to tweet that payload. So we're basically going to handle the error in a match. And I said earlier that I explained how we handle errors. So this is basically what's going to happen. So we do that Homer quote, and this time I'm not checking that error, I'm actually dealing with it. So basically I'm saying I'm going to match the type of the response back from that get. It's either a response, a genuine HTTP response with a text payload, or it's an error. And the error will happen if that endpoint times out. And so if it's an error, then I'm going to do that do. Now, so far I haven't got the circuit breaker, but if I go and grab that a little snippet of code for the circuit breaker, I will show you how that works. So the circuit breaker basically says, let me just cut and paste it into the file. So instead of this Homer endpoint, I've got a new endpoint, which is a circuit breaker endpoint. And what this says is, over a rolling window of 10 seconds, with a bucket time of 1 second, if I get any errors at all, then I'm going to switch off that endpoint and not use it for 3 seconds. So I'm going to give that Homer endpoint time to come back. And here are all the status codes that I consider to be errors. And also, I've got a 1 second timeout. So if it takes longer than 1 second, then also that's going to cause a problem. Now, this is not a genuine internet service. This is one we created, and it does sometimes take longer than 1 second, so we can demonstrate this. So I'm going to use that circuit breaker version of the endpoint to call it. I'm going to get the quote on it, and I'm going to now run that. Now, before I've been compile, build, run, edit, build, run, edit, which is kind of normal, but you can actually run it without compiling it. It will compile it and run it in one go. And now I don't need all that JSON input because it's going to find the quote directly. So all I need to do is do a curl with a post to 1990, and that should have a go. Oh, now the one thing I didn't do was pass my config over. So if I pass that over, twitter.toml, I still need my Twitter secrets. And this time we'll try it. I told you I'd make some mistakes. So now it's given me a do. That means that it timed out. So I'm going to try it again. And you can see in the logs over here that the threshold, the failure threshold, has exceeded, and it's opened the circuit breaker. So now for 3 seconds, no requests are going to come. I'm going to try it again, and now this time it's worked. So if you go look at my tweets, you can see that we should have 2 does, and then we've got an actual quote from Homer. So that's a circuit breaker. That's very simple. Now, another way of dealing with that would be to do some async logic. So let me just show you that very briefly. If I edit that async, what I've done here is just to put all of the logic for that tweeting into a function. So now we have a function which is doing that tweeting, but I'm going to do this asynchronously. So instead of calling that function directly, I'm going to use start, which is the indication to do this asynchronously. And I'm going to return immediately to the client with a 202 response code, which basically says, I've got your request, I'm dealing with it, but I haven't yet finished it. So now if I call that async, I can run that, build and run that, and wait for it to build. And now it's running. And now I can do a few of these, and it's basically responding instantly saying it's async. But if I go to my Twitter, what you'll see is that over time, I'm getting these tweets come in because they're happening asynchronously. The fact that that quote service is slow is not holding anything up. They're just happening asynchronously as it happens. So I've shown you all kinds of bits and pieces, but really we've only just started to scratch the surface. So those of you who know Swagger or OpenAPI, you can basically generate the Swagger for your thing here. So you can do Ballerina Swagger create. I think that's the right. I'm probably going to give you the wrong command here. Anyway, you basically, there's a command that will generate the Swagger for that service as a YAML file. I've shown you all the way through how sequence diagrammatic this is. By just showing you the sequence diagrams, it's generated from each of the code snippets. So for example, here's the asynchronous one, and now you can see that there's a worker that's going to do that tweet asynchronously, which is really nice. And so at the beginning I said that this kind of stuff I think is much harder to do with, say, Spring integration in Java. So why is that? Because, well, firstly, Spring was really designed to be a local componentized model. And I think for that purpose, it's great. But for integration, it's not really an integration simple. If you look at the kind of logic you build, it doesn't really properly capture the integration challenges. You have multiple files, you have XML and Java, multiple Java source files, you've got some kind of complex Maven or Gradle configuration. If you wanted to do everything we did, which included deploying it into Kubernetes, you'd have to go choose something like Spring Boot and then maybe Cloud Foundry to create all the Kubernetes. If we have an API gateway for Ballerina, you'd need to go find the Netflix API gateway. We have a built-in API gateway, and you need to go find another library called Hystrix for the circuit breaker. So I think what we've done in about half an hour from scratch is much simpler and more logical and agile. So what we're really aiming here is not to replace Java and Spring as a way of creating those endpoints, but to replace or to find a new way, a new, more agile, more integration simple way of creating the glue logic between microservices. So if you have your JavaScript, your Go, your Spring endpoints, we think Ballerina is a great way of creating new integrations between them, both synchronous, asynchronous, with transactions and so forth. And there's a whole set of ecosystem that we're really working on at the moment. We have support for things like Rabbit, AMQP. I talked about Swagger and OpenAPI. I'll talk about gRPC. We have plugins for MySQL, Postgres, Cassandra. We have documentation showing how this works really well with service meshes like Istio and Envoy, how it works with etc.d and so forth. The things that I've covered are really just a small part of this. It has unit testing built in. You can build your own annotations and extensions. You can build your own connectors. There's really simple CI/CD integration. We didn't look at the fork join and the concurrency model, which is really powerful. I didn't really go into detail on the union type system in full detail, but we think that the type system really properly reflects the reality of calling network services. And, you know, it's still not a 1.0 language. We're still working, we're still editing it, you know, fixing the language and so forth. We're planning to make it 1.0 by the end of the year in Q4. And there's some discussion about donating this to something like the Cloud Native Computing Foundation. At the moment, it's a Apache licensed open source project in GitHub, and we'd really like your, people to try it out, feedback, and get involved. So you can do that by coming to Ballerina.io. You can go to the platform, or you can join us on Stack Overflow or Slack. And also, I'd really like you to come along to a webinar, sorry, not a webinar, to a face-to-face conference we're having, Ballerina Conf. Somehow I've lost the slide for that. I don't quite know where that's gone. While we're asking questions, I'll get that slide up. And we have this conference happening in July 18th in San Francisco. You can come along face to face, or you can join over the web like today and really find out more details. We've got a host of interesting speakers. We've got people from the community, and I think it's going to be really exciting. So I'm going to end it there, and we're going to open the floor up to questions and see where we go. So while I'm waiting for questions to come in, I did want to mention one more thing that I forgot to present. So you can do Travis builds on this. It's really simple. Here's an example. You basically do a Git check-in, you link your GitHub to Travis, and it automatically builds. And the examples of how to do that are in the Ballerina guides in GitHub. So for example, here's a Travis YAML. You can just take a version of and copy and put into your GitHub, and then link your GitHub repo to Travis. And so that's pretty cool. And I also wanted to briefly mention the streaming support, which is really powerful. The best way to find out these things is we have something called Ballerina by example, which is really low-level language examples, and we have Ballerina by guide, which are higher level sort of things you might try to solve, and the stream processing guide is a really nice example. And everything that I demoed today is in the Ballerina by guide repo. It's a common demo. On my machine, I've got Ballerina 975, and I've got Docker Edge with Kubernetes on it and Visual Studio Code. So that's basically all I needed to do all this. And there's the Ballerina Con slide that I wanted you to see. So I don't know quite how this webinar system works, but let me find the questions, see if there's any questions. I can't see any questions yet. Sam, are there any questions? So I have a question saying, it's not really a question, it's saying Ganesan has said it's awesome and a great presentation, thank you. Well, you're most welcome. I appreciate the feedback. Now, here is a question. So it's a really good question. Ganesan's asked, how is this different from Istio addressing non-functional features such as circuit breakers and etc.? So I think that the best way of putting this is that some of the things, service meshes like Istio, Linkerd, and Conduit are really cool ways of doing some of the things that you need to do in an integration in a cross-language way. And if you are using Istio, Linkerd, Conduit, a service mesh, then obviously we work really well with that, and we wouldn't suggest you do a circuit breaker in there. But not everything that you need to do can be done in that service mesh. So a great example is distributed transactions. Distributed transactions need to understand the programming logic. And we have built in distributed transactions into the language in a very lightweight, microservices-oriented way with no central transaction manager, no single point of failure. It's really powerful. So we can do things in the language which you can't do in a service mesh. So we're not trying to replace a service mesh with this. We're trying to say that when you come to do integration, not all the problems you need to solve for integration can be done in a service mesh. And a language is a really good way of doing them because you have first-class support for programming constructs. and you have agility. I hope that answered your question, Garrison. The next question is there a plan, if not existing, to have predefined dashboards for Kibana, Grafana, and Prometheus? My understanding is that there are dashboards that are part of the samples and the guides for those. I haven't done that myself. I haven't set that up myself, so I could be wrong. But I think we do have. I think we do have predefined samples with all of that ready built. Yes. I'm just going to wait a minute longer because I see some questions are still filtering in. I want to give anyone else has a question a chance to answer it, and otherwise I'll let you get back to your everyday life. So one thing I don't have on this registration is a access code, but I believe that there are some discounts on access for Ballerina Conf. So if you're interested in attending either virtually or not, tweet me at PZFrio, and I will and I'll tweet you back a code, which will, I hope, give you a discount for that. So Jim, you've got another question saying, building off this question, is there a high-level planning for implementing tracing via Jaeger or open tracing? So I don't have a live sample of that, but I do have a screenshot here, and it really is built directly into the system. So what's happening here in this screenshot, this is literally just telling Jaeger where Ballerina is and Ballerina where Jaeger is. It's built in directly. It's like 2 lines of config to set this up. And this is basically passing the right information so you can really do distributed tracing of Ballerina. So I don't think it needs any special dashboards or pre-definition. It just works out of the box to give you this kind of detail, and you can see where things are working, where they're going wrong. So we made a real effort to make sure the open tracing support was really powerful and really understood the distributed nature here. So if you, for example, if you're calling one Ballerina service from another Ballerina service, we pass enough information in the headers that you can see all that happening. Great. So I think we're pretty much out of time, and we've had some really useful questions. I hope this has been useful. Please feel free to contact me via Twitter or just email me, paul@wso2.com, if you have any further questions. And thanks a lot for attending and for sticking around through the whole webinar. Take care.